All right, welcome to page 2 of Polar Notes. On this page, we're going to do some more conversions, not just converting points this time, though, but converting equations. And this is a bigger piece of the AP exam than converting the points. Both are important, but I've definitely seen AP exams where this is actually part of a question where they say show that the following rectangular equation can be written in polar as, or something like that. So you definitely need to do some conversions of equations, and in order to do that, you need to have those 4 equations really memorized. So you need to know x equals r cos theta, y equals r sine theta, x squared plus y squared equals r squared, and tan theta equals y over x. And then you basically just do a substitution from there. So if I want to convert x squared plus y squared equals 25 from rectangular into polar, sure, I could replace x with r cos theta and y with r sine theta, but even better than that, why don't we use this x squared plus y squared equals r squared? That's quicker and a lot easier to deal with. So if I do it here, I would just have r squared equals 25, and then you are allowed to square root both sides and just say r equals 5. So the circle with center 0, 0 and radius 5 is written in polar as just r equals 5. So much easier. That's why polar exists. Now, xy equals 10, I don't have anything over here that says xy, so we're just going to replace x with r cos theta and replace y with r sine theta. And that's equal to 10, so I have r squared sine theta cos theta equals 10. And then if I solve for r, I'm going to have r equals 10 divided by sine theta cos theta square rooted. Now, technically, those square roots have a plus or a minus on them, but you really don't need to worry about that here. So just ignore it and just deal with the positive square root for now. And then last but not least, y equals x squared. So r sine theta equals r squared cos squared theta. You are allowed to cancel this r with one of the r's over there. And if I solve for r, I'm going to get r equals cos squared theta divided by sine theta. No, wow. Mrs. Viver made a boo-boo. Pardon me, I wrote that backwards. Sine theta divided by cos squared theta. Pardon me. All right, now let's see. From there, if we want to convert from polar into rectangular, let me carry these guys down from above. So, what is going on here? Oh, who knows? This computer does some funky things when I try to move stuff. Whoa. All right. So we're going to use those same conversion equations again. But this time, what we usually end up doing if you're going from polar into rectangular is modifying the polar equation first to make it look like one of these and then doing a conversion. So r equals 4. I don't really have anything over here that says just r. I do have r squared though. So the first thing we want to do here is square both sides. So now I have r squared equals 16, which makes it x squared plus y squared equals 16. Okay. Theta equals pi over 6. Well, I don't have theta here, but I do have tan theta. So now what I can do is take the tangent of both sides. Tan theta is y over x. Tan of pi over 6 is root 3 over 3. Now, if you want, you can make that y equals x times root 3 over 3, but you don't have to. R equals 4 sine theta. Well, I don't just have r, I'd like r squared. But if I square both sides, then I have a sine squared, and I don't have that here. And I don't want just sine, I'd really like it to say r sine theta. So I need an r squared here, and I need an r over there. Hey, we'll just multiply both sides by r. R squared equals 4r sine theta. So then I have, let's see, cancel this with that. So then I have r equals 4 sine theta. Whoa, what am I doing? Mrs. Weber, what did you just do? I didn't mean to do that. I got all confused. Pardon me. We are going to multiply both sides by r. Excuse my mistake. I don't feel like redoing this video, so just bear with me. I got distracted by something in my room. Sorry about that. So, r squared equals 4r sine theta. We're converting to rectangular. I was simplifying. We're converting to rectangular. So if I convert to rectangular, r squared becomes x squared plus y squared. 4r sine theta becomes 4y. Now, that's already in rectangular form, but one of the things you could do with this, it's not mandatory, is you could write this as x squared plus y squared minus 4y equals 0. Complete the square, so minus 4y plus 4 equals 4, add 4 to both sides. X squared plus y minus 2 squared equals 4. And now this is rather obviously a circle whose center is 0, 2. All right, give me 1 second to pause. Be right back. So then if we look at the second row, r equals negative 3 secant theta. Well, I don't have any secants over here. So I'm going to think about this differently and think about it as r equals negative 3 over cosine theta. And if I think about it that way, then if I multiply both sides by cos, I have r cos theta equals negative 3. And r cos theta is x. So this is the vertical line, x equals negative 3. R squared sine 2 theta, well, wait a minute, sine 2 theta, let me use that identity. Sine 2 theta is 2 sine theta cos theta. Divide both sides by 2. So then I have r sine theta, r cos theta equals 1, which is really just xy equals 1. And again, if you want to solve that for y equals, go for it, but you don't have to. And then last but not least, f is a lot like c, where we have r on one side and we have cosines and sines on the other. So if I multiply both sides by r, I would have r squared equals 2r cos theta plus 2r sine theta. And r squared is x squared plus y squared, 2x plus 2y. This would be another circle if you wanted to complete the square. And if you did that, you'd have x squared minus 2x plus y squared minus 2y equals 0. Complete the square would mean add 1 twice, so really add 2 to the other side. X minus 1 squared plus y minus 1 squared equals 2. All right, now graphing polar. You can graph polar without your calculator, really just using your noggin and or converting it into rectangular coordinates. So r equals 4 means that you are 4 units away from the origin, and theta isn't involved. So that means you're 4 units away from the origin for any angle you can think of. Well, that's just going to be a circle with a radius of 4. Theta equals 1 means you're going to stay 1 radian away from the positive x-axis. So if I'm 1 radian away, 1 radian is 50 some degrees here. So if I'm 1 radian away from the positive x-axis, that's going to be up here if r is positive, or down there if r is negative. So this part of the line is for positive r's, and that part of the line would be negative r's. So theta equals 1 is really just a straight line. And then r equals 3 cosecant theta. I can't really think my way through this one, so I'm going to multiply both sides by sine. So cosecant and sine cancel. R sine theta becomes y. This is the line y equals 3. Is the same as r equals 3 cosecant theta. And then last but not least, just some graphing polar with your calculator. So most of what I want to talk about here is when you graph polar with your calculator, you have to make sure you're in polar mode, make sure you're in radians, and you want to check your window. So I'm going to get myself down here into polar mode, parametric polar, hit enter. So if I get myself into polar mode, I'm going to, come here you. I'm going to get myself in polar. I'm going to set my theta min to 0 and max to 2 pi in my window, because that's just a good way to go, and it's actually already there. Set your theta step to 0.1. 0.13 would be fine, but I'm just going to make it 0.1. And then the other thing I always tell people to do is when you go into y equals, it all says r equals now because we're in polar. You want to turn on what I like to call the turtle tracer, and that's when you go over here and hit enter. Oh, mine looks different than yours, but basically we want to change my line. No. How do I do that here? There we go. I want to change my line to that line with the key on it. I think it means on your calculators you'd hit 0 like 3 times, and then you'd be okay. So now if I want to graph this, I'm just going to graph sine of 3 theta and just see what types of graphs we come up with. Why is this? Oh, I didn't hit over enough. Sine of 3 theta. And then hit graph. And look at that, it's that happy little thing. And now here's why I tell you to put the turtle tracer on. Sine 3 theta actually graphs twice from 0 to 2 pi, and that'll be important later on. So there's this one. Let me shrink it a little bit. And then if we have r equals 1 minus cos theta, let's go back here. R equals 1 minus 2 cos theta. And I graph that one. This gives me this big loop-de-loop with a loop inside of it. So that's unique. There's that one. And then 4 sine theta. Well, when we did sine 3 theta, we got petals. When we do 4 sine theta, let's see what happens this time. 4 sine theta is a circle centered on the y-axis, and it actually goes around twice. Again, that's not important now, but it will be later. And then 2 times 1 plus cos theta. And we have 2 times 1 plus, nope, not 11, plus cos theta. And then if we graph that, we get this thing, which is a cardioid, because it kind of looks like a heart-ish. And I always say it's an asteroid because it kind of looks like a sideways butt, but you know, that's high school humor for you. So, cardioid circle, loop-de-loop thing, and we got some rose petals over here. There's graphing polar, and we are done with polar notes, page 2.